All right, so last section, we are just going to get an introduction to polar coordinates. So we're going to talk about how to plot points in the polar coordinate system and how to convert between our rectangular coordinate system and polar coordinates. So how to convert between rectangular form and polar. So in our rectangular coordinate system, we just move up and down, left and right. With polar coordinates, now we're dealing with a direction and an angle. So our book offers as an example um, of a real life application of polar coordinates, that if you were trying to model a person's position on a Ferris wheel, then polar coordinates may be more useful than the rectangular coordinates. Okay, so here's the polar coordinate system. Okay, so polar coordinates in the form of r and theta, where r is a directed distance from the origin and theta is a directed angle from the polar axis, which is this here. This is the polar axis, so how far we rotate away from that gives us the angle theta. So if we wanted to plot something like for 5 pi over 6, we would find the angle 5 pi over 6, which we know is in the second quadrant, right now. Yeah. And so we'll go to that angle, and counting from the origin out, we need to go 4. So 1, 2, 3, 4 is that point right there. So it's at the angle 5 pi over 6, and it is 4 units away from the origin. So let's do another. Let's say we want to plot the point -2 and 7 pi over 3. So 7 pi over 3, that is more than 2 pi. 2 pi is 6 pi over 3. So we would go all the way around the circle one trip and then go pi over 3 more. So the way this is labeled, well, the way this is drawn, this is a pi over 6. So this is pi over 3. All right, so one trip around gives me 6 pi over 3. I'll go one more pi over 3 to here. This is going to be 7 pi over 3. And you can see that these two angles are coterminal. The difference between them is 2 pi. So bringing the whole semester full circle. Okay, but as far as the -2, instead of counting from the origin out towards this arrow that I've drawn, for -2, we're going to go back the opposite direction. The same angle, but back to this way. So maybe you notice here that -2, 7 pi over 3 is not the only way to represent that blue point that I've drawn. There are several different. So in our rectangular coordinate system, each point is unique, but in polar coordinates, there are multiple representations for angles. Now, here are the relationships between polar coordinates and rectangular coordinates, so we can use these equations to convert between the two forms. So let's try it. Let's try this example, and we're given polar coordinates, and we want to change them into rectangular coordinates. So we have these two equations on the left that tell us exactly how to find x and y using r and theta. So what we are given here, 7 is r, and 3 pi over 2 is theta, and we're kind of just going to plug them in to these equations over here. So x is equal to, I'll put the formula here, but from the numbers we're given, this will be 7 times cosine of 3 pi over 2. And we just evaluate that to find our x coordinate. And 3 pi cosine 3 pi over 2 is 0. So this is going to equal 0. So x is equal to 0. Now our y coordinate is given by r sine theta. So that's going to be 7 times the sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. So our y coordinate is negative 7. So in rectangular coordinates, this point is 0, negative 7. You can check this graphically. If you graph both of these points, they should appear to be at the same place. So we know 0, negative 7 is going to fall on the y-axis. It'll look like that, roughly. In polar coordinates, if we rotate to the angle 3 pi over 2, that's this angle down here on the bottom of the y-axis, and we go out in this direction by 7, we end up still somewhere down there on the y-axis. So they do appear to be equivalent. Sometimes when you use these formulas, you're going to end up with square roots, because when you evaluate sine and cosine, sometimes you get square roots, and that's okay. Just leave the square roots in your rectangular coordinates. So let's do one going the other direction. Let's take the rectangular coordinates negative 1, 1, and we're going to convert to polar coordinates. So this time we're using the other side of these formulas, and we're going to use x and y to get r and theta. Okay, so let's do r first. R squared is x squared plus y squared. So I'm just going to plug in the x and the y that are given to me. So r squared is equal to 1 plus 1. R squared is equal to 2. So that means that r is got to be the square root. And then to get theta, we're going to use the equation that says tangent of theta equals y over x. So tangent of theta for this problem equals 1 over negative 1. So we got to solve this equation for theta, whereas tangent equal to negative 1. And that is going to happen at 3 pi over 4. So this is only one angle in polar coordinates that corresponds to the point negative 1, 1. Because I took the square root, so really I should be saying plus or minus. R could be negative. And also there are other angles that give me a tangent value of negative 1. So I would always plot it just to get an idea where this point falls. It's in quadrant 2 when I plot it, the point negative 1, 1. So if I'm going to use the angle 3 pi over 4, which is in quadrant 2, then I need to be using a positive value for r. There's also a tangent value in quadrant 4. There's also an angle in quadrant 4 that gives me the same tangent value. If I use that angle, then my r would have to be negative. So I highly recommend plotting just to make sure your answers are agreeing and making sense. Last thing is converting an equation. Okay, so we're going to use those same equations to convert this equation from rectangular form to polar form. So I'm just going to substitute for x and y what we have there in the identities. So x was equal to r cosine theta. So I'm just going to plug in for x, r cosine theta. And it's still going to be squared. And then y was equal to r sine theta. So I'm going to replace y with r sine theta, still squared. And now I'm just going to simplify and solve for r. So here I'm going to get the r is going to be squared and the cosine is going to be squared. and then r squared sine squared. And I'm going to try to simplify this. So I see r squared in both terms, so I'm going to factor that out. And there inside, I've got a familiar identity. I know that that is equal to 1, so I've got r squared. All of that is equivalent to 1. So this just says r squared is equal to 9. And then using the square root to get r, we find that r is equal to 3. And you may say, well, I took the square root. Why can't r be -3? And it can, they honestly would be equivalent. Because r equals 3 is just going to represent every point on my polar coordinate system that is 3 spaces away from the origin. So let's say that's 1, there's 2, there's 3. So every point on this circle satisfies the equation r equals 3. And since it's in every direction, r equals -3 would still satisfy that. And you can tell from the rectangular equation, x squared plus y squared equals 9. That's a circle with a radius of 3.